Welcome, everybody, to this to a short discussion about the 4 2-year international master programs we have in materials. We actually have also 2 5-year programs, civilingenjörsprogram in materials, but they are not invited today. We're not going to discuss them today. Today is the discussion about these 4 2-year programs. And we have 4 programs, and we have 4 program responsibles, which means that you are responsible for the curriculum and also for the quality of the programs. Is that correct?
Correct.
Yes. And you're also responsible for other things concerning the students and so on, and a lot of different things you have to do when you work as a program responsible. It says the heading says that we should have 3 quick questions. So there will be kind of 3 questions, and we will start with questions about a question about the aim and the content of the programs. So each program here each program responsible will present in a short, some sentences, some minutes each program. So we start with Håkan Rensmo. I think I use this one. And you will talk about the quantum technology master program.
Yes, so I say something about the quantum technology program, which is aiming for students with a strong background in physics and in technology, ranging from our typical bachelor students that we have here and the people that take the civil engineering technical physique that we have. Somewhere there, that's the spread. In the program, you practice a lot of different skills. It will both be theoretical skills and experimental skills in this area. Core courses that reflect a little bit the content of the program are, of course, then quantum mechanics. That is the foundation of what is done in the program. And then there are courses in photonics and quantum optics, optoelectronics, spin-based technology. And then there are also courses in second-generation quantum technology, which is also reflecting a little bit the width of the content of the program. In principle, you can put together different courses, but have different tracks. Something that is heading more towards, I would say, modern physics, then something that is more applied physics, a little bit of applied quantum technology, and then something that is more directly the second generation quantum technology with quantum computing and things like that. And then you can, after that, go to do a PhD or go to industry in these different areas. I think that was
something. And this today, in the morning, we had a very interesting lecture and also nice presentations from about quantum materials. So how much materials do we have in this program?
So I would say that, of course, all the technology are built on materials. So there are a little bit of materials, definitely, but it's more towards using the materials than producing the materials. And that is maybe a little bit different from the next program that we will talk about.
That was a nice transfer to the materials science program and Professor Biplap Sanyal.
Okay. So basically, when we think about material science, we think about physics, chemistry, engineering sciences, everything together. But there are different purposes for every program because the goals are a bit different. So the goal of this material science program is to give a fundamental understanding of materials. And you can see that from the picture, we have the periodic table containing all the elements there and their crystal structures and their electronic structures, which we can only understand from the behavior of electrons and atoms. So the main purpose of this master program is to combine physics and chemistry together. And therefore, we have 3 tracks. We have a physics-oriented track, which is quantum materials. We have a chemistry-oriented track, which is soft materials. And we have a joint track where both physics and chemistry students can take, and this is energy-related materials. And all of you know that how important energy-related materials are these days. So in all these courses, we have designed courses in such a way that some of these courses have both theory and experiments together so that the students get the possibility to be exposed to both of them. And interdisciplinarity is covered in project-related courses. We have 2 interdisciplinary project courses where physics and chemistry students come together and they share their knowledge. And of course, we want to take advantage of fantastic materials-related research in Ångström Laboratoriet, both from theory and experiments, and thereby utilizing also like big infrastructures like Max 4 ESS and the theory behind all these things. So courses are strongly connected to in-house research, which is very important, education and research club together. And yeah, in one sentence, I can finish with that. The primary goal is to have the fundamental understanding of materials properties.
Yes.
Yeah.
And your program reflects that materials is not a one discipline subject.
Absolutely.
You really need different disciplines.
We have to have that, absolutely.
Yes. Yeah. And now it's very exciting because there is some confusion about what is the master program in material science and what is the master program in materials engineering? Why do we have 2 programs? So now we will listen to Mikael telling us about the materials engineering, and we will see if we can find out the difference.
If you can see any difference.
Yeah. Please.
So this program started 2 years ago. So this means that the first students are now struggling with their degree project. It's going well for them. And this is a little bit special, this program also, that most of the courses they are reading together with Swedish students on this civilingenjörsprogram called Q&K-programmet. And this means, I think, that we have a really good mixture of students with different background. So that's a good thing with this program, I would say. And okay, what's the difference then? I would say that this program is a little bit more application-oriented. You are more into theory. Of course, we also have theoretical courses in this program also. But I have listed some of the core courses in this program. And what I mean with applications-oriented then, you can see that by the courses in micro and nanotechnology, where the students actually learn how to structure different material on the nano level. And for a wide range of different applications. It can be for optics, biomaterials, mechanical components. So it's used for a lot of applications, and they also master the different fabrication processes. So hopefully they can go out to the industry and develop these type of processes also. It's the same for thin film technology, and this can be used, of course, for protective coatings, solar cells, and much, much more. And then we have a block of courses in biomaterials, where they teach us what materials to use in different applications, if it should be implanted in blood, in tissue, or bone, and so on. And the same goes for the materials in energy system, where they get familiar to use different materials in different energy applications. And then we also have some courses in fracture mechanics or materials testing. And I know that's very needed from industry like Sandvik and so on. I think it's difficult to get students from this area. But we have many courses in that area. And then we have just shortly the mandatory courses. So like surface characterization, material analysis, and materials and sustainable development. That it's a very important topic in materials engineering. Because I mean, the availability of raw materials is finite. So it's a strong need to develop new sustainable materials and technologies. And to do that, you need to have knowledge in materials engineering. And we have some specialties also in this program. So you can choose to be specialized in engineering materials, medical materials, or energy materials. And just shortly about the career, I mean, We have this similar Swedish program, and we can see that more than 90% of the students has a job within 1 year after the exam in the relevant area. And I cannot see any reason why it should be differs in this program.
Okay, I think that was, you both gave a good picture of the program, so we can see the difference. At least we can see the difference. And then we have the final program, and we have talked a lot about additive manufacturing this afternoon, and we have listened to different talks about additive manufacturing. And we can see that it's a big thing going on in the industry. So how can we contribute to this movement with additive manufacturing? Urban, please.
Yes. Movement, it's a revolution, isn't it?
Okay.
Yes. We're living in a revolution. A revolution not only transforming industry, but it's also transforming society. Everyone can print with a printer today. You can go down to the downtown and buy a printer and start printing right away. The difference, I would say, is that you need to know how to do it in a good way. Claes Marteleur said an hour ago, he said, printing a component with the correct dimension is one thing, and then we have to know more to do it in the correct way. I would like to start even before that. I mean, everyone can print something, but they don't really know even how to get the dimensions correct. So this program is actually necessary to get to make us be part of this revolution. So this is a 2-year program in which we aim to attract students from different areas. It could be mechanical engineers. Very many mechanical engineers are taking this program, actually. It could be physicists, chemists, and material scientists, of course. So we have different background. We give them a sort of customized introduction time in the program. And then we have a number of different areas where we train them. And that is, of course, the same areas that both Peter Ahlin and Claes Marteleur was talking about. How do we produce the feedstock, the powder itself? How do we use additive manufacturing in the different material classes doing the printing? How do we do it in industry? And how do we optimize the structure to make a topologically optimized design, for example? And how do we make sure that we do it in the correct way? We need to do some process simulation. And of course, we have to do the post-processing. We believe that once these students that has taken this program are finished, they will be able to use the technology in a proper way, to make use of it in a good way for different reasons, for different purposes. And they also should have a very good knowledge and to be able to judge when to use this technology instead of using traditional manufacturing. So being able to use the additive manufacturing in the proper way is a very large aim of this program, you could say.
Yeah.
Yes.
And you have involved industry representatives in designing the programs and so on.
Both in designing and also during the program. It's a lot of participation from industry, both in visits, in lectures, and in laboratory work. So it's heavily involved. Industry is heavily involved in the program.
Is that easy? Do you agree about the student skills, what they need, and so on? Or
in a normal time, I would have said it's quite easy because industry is transforming, and they are eager to get students that have this kind of training. During a pandemic, it's difficult to visit the companies, of course, but otherwise it has been quite an easy ride to get industry involved in this program.
But if we continue with question number 2, why is it good to run this kind of programs at Ångström Laboratory? If you start with you, Urban, why is Ångström the best place to have a master program in additive manufacturing?
Like Cecilia said, we have a strong background in materials, and this is an AM program oriented towards material science, and having a material science aspect of AM. It's not really into structural design as such. It's more like the material science behind it. We also have this AM center, of course, and we have large projects supporting this program. And of course, we have an industry around us. We live in an area, or we sit in an area where we have a lot of industries that are very interested in this technology. So it's very easy, and it's a good spot. We have a good interest and collaboration all around.
And Mikael, why is the Ångström Lab the perfect place for materials engineering?
Yeah, as Urban told you, we have a lot of really good research group here in materials engineering and material science. So that's one obvious reason, of course. But I want to point out the fact that we have the clean room lab here, that Ångström Lab. Maybe some of you visited today. And this is super important for the material research, I would say, because we have the process part where we can do the micro and nanostructuring of all different type of materials. We have the thin film technology where we can deposit material of different qualities with sputtering, evaporation, and so on. And also the analysis lab with all the surface characterization equipment, transmission, electron microscope, AFM, XPS, and so on. And since we have this great facility, we also have a lot of great research group that works in this clean room. And of course, then it's a bonus for us to use these researchers as teachers in our courses. So this is perfect. That means
and the student gets access also to all this
exactly.
equipment.
And they also do some elaborations and so on. So this is a perfect match, I would say. And also, besides that, we have a lot of high-tech startup companies, especially within life science, but also in other areas. And it's a strong need for people with materials engineering and material science background in all of these small companies. So I think we must have a program in materials engineering here. And now we have it, so I think it's perfect.
And in material science, is it so similar? Or?
Well, I think I resonate with both of them. It's absolutely correct that this is an ideal place for these kind of activities because we have outstanding researchers here, both in experiments and in theory. That is absolutely clear for many years. We are doing state-of-the-art research here. So just to add on the theoretical component, so we have fantastic research groups here in theory and computation of materials. And we have fantastic collaboration between theory and experiments, which is also very good for the students. So they can go from one part to the other very easily. So I think, and also, we have these big infrastructure facilities, big supercomputing facilities, so that the students can get access to big data, machine learning, and you name it, artificial intelligence, all the buzzwords. So I think they have enormous opportunities, and we have to take care of that in a proper way, and the students can really benefit from here.
Yeah, and we have both very strong materials chemistry and materials physics, which match in your program.
Absolutely, and
and maybe the student can be a bridge between.
This is a fantastic opportunity for the students, but also it's a great opportunity for us. Like I come from physics, and I have chemistry colleagues there, so we get to know each other more actually, and there is more scope of increasing collaboration between physics and chemistry. We basically speak the same language. Our presentations are a little bit different, but at the end of the day, we are all on the same platform, I think.
And that is very good for the students to learn.
That's fantastic, I think so.
Yeah. And Håkan?
Yeah, I can only, agree what has been said here, that we have the interdisciplinary environment for all these things. Maybe what I could add to what is already said is the large-scale facilities that we have strong links to, where I think through this researchers here, the students really can get hands-on experience in Newton scattering or X-ray methodologies, which is, I would say, a bit unique that we have that close connection. Also, the Tandem Lab is an advanced place where people really can get hands-on and learn things by that. So that's maybe what I can add to what is already said.
What do you think you can? We have 4 programs. Do you think you can gain a lot by collaborating, Or you will also work with the engineering physics program, of course.
Yes, and I mean always what have been said. The theme of today have I think been that Ångström is a meeting place for meeting people thinking a bit differently, all the way from very applied stuff to skills that can be used in future applications that we maybe not know of today.
Okay. Let's talk about the future, then, especially the future for the students. Why do we need this education for the future develment on future technology and so on? Mikael, you can start.
I can start. It's totally okay. I just want to point out.
What do you think about your students now when they become alumni?
No, but I think it's important because for instance in biomaterials, it's a fact people are getting older and older. We need to be able to replace different parts in the body. So the students to help to be able to get even better biomaterials in the future, we need to have people with a good background in materials engineering and material science. That's quite obvious. And the same goes for the batteries. So now I just bring up some topics that I know we are strong on here at Ångström also. And we are about to shift all the petrol cars to electric cars or all vehicles. And that means that we need to develop even better batteries. And to do that, we must have knowledge in materials engineering to solve that type of problem. Same with solar cells. We need to have the skill when doing the deposition of thin films with different methods. And you need materials engineering. So I think to be able to solve these type of questions in the future, we need to have students that have a materials engineering, material science background. So I think it's a bright future here.
And what about material science then? What do you think about your future Nobel Prize winners?
Well, I cannot guarantee a Nobel Prize winner, but what I can say, it was absolutely clear from Professor Nicholas Paulding's talk today that there are many things which come to us as surprise that we never think of today, but it can come to us as a surprise tomorrow. So future is very important for us, and to understand technology for future, we need to train these people to have a very good understanding, fundamental understanding. Otherwise, what you said, we can actually provide a fantastic education for achieving those goals that you have set. So I think it's very important, like we have hard things like topology, quantum computation, which are looking into the future, like energy efficient devices and all these things. We need to know the fundamentals of this, and if we can train the students in a good way, they will jump into these future activities, and I think they will be very successful. So we have plenty of things to offer.
Håkan, do you have something to add?
I think you said it all. I would say you covered a lot of aspects there, but I think again, from today, it is important that students are ready to take on new challenges, so to speak, and there in the quantum technology arena, then the understanding for quantum effects grow quickly now. So we have to be ready to take that challenge on and develop new technologies. I myself had some thoughts about new ways of thinking about photovoltaics of today, which are more linked to, I don't know, ferroelectrics and other things.
We heard in the session before here, Håkan Enku said that he had heard someone saying that we were educating here in Scandinavia or Sweden, we were educating for serving and not for creating. So it sounds like you want to have a program that inspire the students to creativity and to think about new things.
Ready to
that's a big goal. It's a challenge, of course, but it's.
But again, skills is something that we always can bring to our students.
Yeah.
And with the skills, they will be able to take care of the future.
Any innovation needs enormous creativity, so
Yeah.
we cannot disregard that. So I think that's the fundamental thing.
Yeah. And Urban?
Yeah, additive manufacturing is a little bit different. I mean, it's very applied, of course, and it's a new tool in the landscape of production techniques. And new production techniques usually brings a little bit new materials, and new materials brings a little bit requires a little bit new production technologies and so on. But this time it's quite different. It really opens up for quite a number of new materials. So I just congratulate the students that are in the program right now. They are in a front seat. I mean, they have all the possibilities to be taking part in this development of new materials, which requires, of course, that they know a lot from the theory about the materials to start with. Otherwise, they will not be successful. But really, I congratulate my students. Yes.
Yeah. And I think all of you have also included sustainability, and that's really an important aspect that is really important in the industry. It's really important in the research, but it's also something really important in the education. And I know that you all have thinking about this and how to include it and how to work with it. So that's also something we can congratulate our students, our present students, that they also get this kind of aspects and this broad thinking about what they are doing. Yes, now we have used the 3 questions, and I think we have finished. If you don't want to, do you want to add something? Something missing?
No, I mean, what you were talking about, Håkan, I think some of the courses are giving to all the programs, so we have some overlap. I, for instance, will have some additive crash course in additive manufacturing. I know we have a lot in optics like you have, and also that. So there are some overlap actually. I think that's super actually.
Yeah,
so
that's good.
Yeah.
Okay. Do I have one question? Yes, Lotten.
No, I was wondering how you think about the attraction of students, because I think, the job market is great, as you've seen, and it's going to increase. The research connection is great, but how do we convince students who don't know that yet?
This question I was very tempted to ask while there was a discussion going on. So I feel that our visibility, our material scientists' visibility is not so great in the society still. Whereas the visibility of life sciences and medicine, it is much more. So people can relate, common people in society can relate themselves very easily compared to what we do here. So we need to work on it really hardly. Really, we need hard work to reach the common people. So that people can understand the importance of material science in everyday life, which we understand, but a lot of people still do not understand that. So if that gap is filled, I think students will automatically, or their parents will also be motivated to talk to their kids about material science one day. And that is, I have a strong hope for that.
Yeah. We have to work together.
I agree. I think this can be a good start for us.
Yes, I think it's a good start for you.
Because it's a relevant question, actually, and we're working on it, and we have to find out a good way. Thanks for the question.
Okay. Thank you very much for presenting your programs and discussing
Thank you.
your programs.
Thank you.